Okay, so we are now in our part 3. So let us solve the other examples. So we have number 2. So find the equation of the parabola with vertex at 5, negative 2 and focus at 5, negative 4. So number 2. So say this is our Cartesian plane. So we have this vertex here. Vertex is 5, negative 2. Then the focus is 5, negative 4. Okay, so the concavity is downward. Okay, because the focus is in here. Okay, so take note that the distance from the vertex to the focus is equal to, that is distance p. Okay, so you have negative 2 here and 4 there, so therefore our p is, if we count it, so negative 2, so negative 3, negative 4, so we have 2. Okay, so p is equal to 2. So with this concavity that we have, so the standard equation for that is x minus h squared is equal to negative 4p, then y minus k. So we have x minus 5 squared is equal to negative 4 times value of our p2, then y plus 2. Okay, so since this is negative 2. Okay, so expand, so you have x squared minus 10x plus 25, then you have negative 8y, then negative 16. Okay, so what we do in order to get this is negative 4 times 2, so we have negative 8, guys. Then we have y plus 2. So what we did is just distribute this negative 8 there. Okay, so negative 8 times y, this one. Then we have this negative 8 times 2, so we have negative 16. Okay, so simplifying, so therefore we have x squared minus 10x plus 8y, so plus 41 is equal to 0. Okay, so that will be our answer for number 2. Okay, so you have to analyze it with a given, respective given. Okay, for number 3, so determine the equation of a parabola with focus 4, 2, and the electrics of y negative 4. Okay, so again we will try to graph it. So again we have this Cartesian plane. What we have is our focus 4, 2. Okay, so 4, 2, meaning 1, 2, 3, 4, then 1, 2. Okay, so this will be our focus 4, 2. Then we have the electrics equal to y is equal to negative 4. So that is 1, 2, 3, 4. Okay, so negative 4. So this will be our electrics. So electrics so that is y is equal to negative 4. Okay, so in order to get the equation of this parabola, so we have the dielectrics there. Okay, so take note, we have the dielectrics there, then we have this focus here. So meaning our parabola is concave upward. Okay, concave upward. Then take note, recall that the distance between the focus to the dielectrics is equal to, and that is equal to twice of P. Okay? This twice of P if we go back to the illustration. Okay? So we have this focus here to the directrix. Okay, take note from the vertex, this is the vertex, to the focus, so we have P distance. Then from the vertex to the directrix, you have P distance. So therefore, the distance between the focus and directrix is equal to 2P. Okay, so that concept will be used here. Okay, so we can directly count it, okay, from the focus to directrix for us to get the value of 2P. Okay, so from positive 2, so 1, then 2, then 3, 4, then 5, then 6. Okay, so their distance is equal to 6. Okay, so therefore P is equal to 3. Okay, so if P is 3, then we can also determine the value of our vertex. Okay, so from the focus, so we have P distance from the vertex, so 1, 2, and 3. Okay, so our vertex is equal to 4, negative 1. Okay, so now what we will do is say this is the graph, guys. Say that is the graph, okay, for our parabola. Okay, so we have the vertex already, and we have also the P value. Okay, so from the equation, when our parabola is concave upward, so we have x minus h squared is equal to 4P, then times y minus, okay, so positive. So we have x, then our h is this 4, so negative 4 squared. So 4 times P is 3. Then you have y, then our k is negative 1, so this is plus 1. So we have to do is expand this one, so we have x squared minus 8x, then plus 16. Okay, so this is the expansion of this equation. Then we have to distribute that 12, then y plus 1. So distribute, then distribute. So that is 12y, then plus 12. Okay, so therefore the equation is x squared minus 8x minus 12y, then plus 4 is equal to 0. Okay, so that is the equation for this parabola. Okay, so that is for example 2 and 3. So part 4 will be the application of the concepts of parabola. Okay, so stay tuned for part 4.